Hi, this is going to be a short video to introduce you to the PCB Flow Analysis Definition Manager, what we many times refer to as the ADM for short. Once you have downloaded the application from PCB Flow, you're ready to create and manage your classification sets. So in this video, I'll explain some of the key features of this tool and hopefully give you the understanding and confidence to start creating your own classification sets today. So let's start by showing you where you can download this application from. First, you will need to log in to PCB Flow as a manufacturer, which can be found at pcbflow.com. And along the left side, you'll see an icon called DFM Profile. Let's drop down into there. Once there, down in the lower right, you'll see an icon that says how to create a DFM profile using ADM app. Once we select that, we'll be presented with a window where we can download the ADM app. After you've installed the application, let's get started by opening it up. Along the left side pane, you will see your list of what we call classification sets. And by default, you will see these two samples to help you better understand what a classification set might look like when you're done completing your own. Now, within each of these sets, you can have individual classifications, or you could also think of them as different technology types. Let's start up here by explaining some of these icons. You can easily create a new classification, save an existing one, import, download, or upload to PCB Flow, and check for updates from PCB Flow. You can also copy, delete, and rename your classification set. And the last icon here is where you can toggle between imperial or metric units. You can also get to many of these commands with a right mouse button click in the classification set area. It's important to understand that each of these classification sets will have different classifications, constraints, factors, and analysis configuration settings, and each classification will have different constraints. The purpose of the classification area is where you would manage your different technologies that we refer to as classifications. You typically want to create your lower technology level to the left and higher technologies as you move right. These can easily be reordered by dragging the column. When the analysis is ran using the classification set, say for example, for this master sample mill, the system will evaluate all these factors, and the farthest left column that passes all the values will get the assigned classification. And in turn, all constraints associated with that classification within the constraint area will be performed on your design during the analysis. So if, for instance, the design you were analyzing has typical trace-to-trace spacing on inner layers greater than or equal to 4.5 mils and greater than or equal to 5 mils on the outer layers, and so on down the column, this 5 and 5 mil classification will be used, and all the constraint values associated with that classification will be utilized for your analysis. Even if all the other values to the right pass, they will not get performed as it will use only the leftmost column that passes. Okay, hopefully you have a feel for how the classification assignments take place. Let's talk about how you build them. As you can see, each classification set has these 4 tabs. For this demo, we're going to start with factors, as they are kind of the foundation for the other 2 main tabs, classifications and constraints, as they utilize the factors that we're going to add here. As you can see, we have 2 tabs within the factors area, one being classification factors that drives the classifications that we set up within the classification tab, and the other tab, constraint factors, drives the factors from within the constraint area. What we're doing is basically filtering on all the many different design factors available for each of these areas and selecting only the ones we wish to use or see within the classification set. As you can see in this sample classification set, the classification factors match what we're using in the classification tab assignment area, while the constraint factors will align with the factors we use in the constraint area. While other classification sets can and likely will contain different factors. Let me better illustrate that by walking through creating a new classification set. When I jump over to factors, by default, the classification factors tab is empty, and the constraints factors tab has only two system defined factors, but you can easily add new by selecting the add factor icon up here in the upper right and then selecting the desired factor. So let's go ahead and build out this new classification set. So you can see these are the factors available within the constraints factors area. And then we'll jump over to the classification factors tab. We have factors that can be used for classifying the design. For this demo, I'm going to add a factor for layer count, which we will use in the classification tab. Then I'll jump over to the constraints factor tab, add layer position in the matrix, as well as copper thickness. These option values are utilized in the constraint tab. So an example of this is I plan to set different constraint range values of 1/2 ounce and 1 ounce copper thickness. So I need to set the option for that here. Let's start by adding these, but later on the fly, we'll probably come back here and add 2 ounce so you can see how that works. Layer side is fine with the inner and outer. We'll stick with that. Now that I have a couple factors to work with, let's go create some classifications and constraints. By default, you can see here we have a standard classification that was created. We could easily rename that if we needed, as well as add more classifications. We'll leave it with just standard for the moment and come back to it shortly. We need at least one factor to get started, so I'll go ahead and select the factors. As you can see, only the factors that we added into the classifications factors tab are available to us here. So we'll go ahead and select layer count, where you can see the default value came in, but we can easily override that here. So now let's jump over to constraints to see the effect of this. I'll expand the etch and general copper spacing. General copper spacing is what we would call a parent level, and it's designed to group similar type checks together. So I can set a value at this parent level and all other checks below it will take the same value. Then I can just go to any of the individual checks below it and override those values. It makes the input process much quicker. When I select factors, you can see I have access to a number of factors for this check. Let's select them one at a time so you can see how it builds up the constraints. Now we could simply select all of them, but for the sake of this demo, I want to build it out slowly, hopefully to better illustrate how it works. You can now see that I have the standard classification that I can assign a value. For this exercise, let's set it to 5 mils. Now let's add copper thickness. And because we added 1/2 ounce and 1 ounce within the factors area, you can see that those came in. Now that gives us the ability to set different values based off different copper weights. Now let's jump back over to the factors area and let's add 2 ounce. And now let's go ahead and jump back over to constraints, and you can see it included the 2 ounce weight. Now let's go back over to the classification tab and we'll create a new classification called advanced. We can change this layer count value, say from 4 to 64 layers. And of course, you would want to add whatever factors needed here to identify and classify based off your designs, such as some examples we might want to add here would be like trace to trace spacing, trace width, or any of the other factors available to properly classify your design. Now, when I jump back to constraints, you can see I also have advanced classification that automatically has been included. Now let's add the layer side factor. As you can see, the inner and outer gets included, and I can set different values based on different classifications as well as different factors. I'll quickly add some values here just to show you how easy it is to add multiple values at a time, as well as the availability of copy and paste with the use of the right mouse button. Then as I look at the child level checks below the parent, you can see that they all took on the same values. If I want to change any of these, it's very simple to do. And as you can see, once I make a change, it indicates in red, indicating it hasn't been saved yet. And once saved, you will see it is bold, so you can easily identify the differences from the parent level. Of course, as you select each constraint, you will get a graphic image and description of that check to better understand what checks are being performed. Okay, now let's jump over to one of the sample classification sets to dig a little bit deeper. If I select the micron version, I would want to change the units so the values are clean. In this set, I simply have a layer count factor as a placeholder, as all designs with at least one layer would pass. But I could come in here and set the 8 and 8 mil less than or equal to 4, and maybe the 5 and 5 mil from 4 to 12 layers, and maybe the 3 and 3 to less than or equal to 64 layers, and so on. I also want to note this will not have any effect on constraints, as we're not adding or deleting classifications. We could rename these classifications as well, and the names will automatically change in the constraint tab for this classification set, but the values within the constraint area will be maintained. To remove a factor, simply select the factor button and turn it off. And again, it will not have any effect on the constraints themselves. Now let's just take a quick look at the constraints of one of these samples. As you can see, none of the children under these first two parent level constraints have bolding, so they all match the parent level. When we review the checks themselves, you can see we are making use of the 4 classification sets, which we can filter on, as well as we can filter on any of these other columns as well. And we are making use of the layer position within the matrix, as well as the copper thickness. Now, I didn't mention this earlier, but tolerances is very important as we work with the 3-color system, red, yellow, and green, where red are the worst case violations, yellow is manufacturable, but pushing the edge, while green is more manufacturable. When I select the tolerance button, by default, we are using 15% from the value you entered, which we use for the yellow value. So when I select the red, you can see the values drop by 15% and the reverse for the green. You can easily change these tolerance levels for each check if you prefer. Now, when we drop on down to General via Annular Ring, you can see that the power and ground via annular ring is bold. And when I select it, I can see the bold values within it, which indicate they're different than the parent level. I also want to point out for each category, we have a constraint called general, which is where the constraint types that do not require a value would fall. And these constraints are simply a on and off setting, such as checks like wide trace narrow pad or stubs and those types of checks. Additionally, we have a filter option where if I wanted to filter out, say, fiducial type constraints or say solder mask checks. Having the ability to filter on the various constraints greatly simplifies the process of managing your constraint range values. And that wraps up this demo. I hope it was helpful. I would suggest you spend some time reviewing these samples to help you understand some of the factors that you might want to use within each constraint. If a sample is similar to what you're looking for, and you can simply copy it, make the necessary changes, and make it your own. Once you have completed all your desired settings, don't forget to save the file and you're ready to upload the file to PCBFlow.